Hey everyone, and welcome to this explainer. I am super excited you're here today because we're going to take the concepts from Chapter 4, Home Automation, and transform them from just words on a page into a real-world inventor's journey. We're looking at how this material gives us a literal blueprint for building things that operate all on their own, using circuits and some clever programming. If you've ever looked at the tech around you and thought, how does that actually work? Or better yet, how can I build that myself? Well, you are definitely in the right place. Let's dive in.
Okay, here's our roadmap for today's build. 1. The automation solution. 2. Tools of the trade. 3. Crucial safety rules. 4. Building your system. And finally, 5. Review and reflect.
Section 1, the automation solution, identifying the problem. You know, every great invention out there starts with a headache, an issue that just needs solving.
So I want you to picture this scenario. Think about your classroom exactly when that final school bell rings. What happens? Absolute chaos, right? Everyone just bolts for the door. But in that rush, the lights and the ceiling fans, they usually get left running, just spinning away in an empty room, simply because nobody remembered to flip the switch. It's a totally normal human error, for sure. But day after day, that oversight wastes a massive amount of precious electricity and steadily drives up those utility bills. That right there, that is our core problem.
The solution we're after is home automation, which is operating devices at home or school automatically with the help of technology. Think back to our empty classroom. Imagine if that room was equipped with an automated power system hooked up to a motion sensor. The system essentially thinks for itself. It recognizes when no one is left in the room, and when zero motion is detected, bam, it automatically turns off the lights. It's an incredibly simple technological tweak, but it saves energy, cuts costs, and is a perfect example of how we can bring modern efficiency into everyday buildings.
All right, Section 2. Tools of the trade, gathering your weapons. We know exactly what we want to achieve. Now we need to figure out what gear we need to pull it off.
Before you even touch a wire, you need some foundational knowledge. You absolutely have to understand and be able to draw simple electronic circuit diagrams. I'm talking about knowing the symbols for batteries, resistors, and LEDs. Honestly, it's like learning the secret language of electronics, and being fluent in it is an absolute must-have prerequisite for any aspiring inventor.
Alongside reading those diagrams, you're going to need some hardware. Specifically, the chapter highlights 3 primary sensors that basically act as the eyes and ears of your automated system. You've got the motion detection sensor, which is exactly what we need for our classroom lighting problem. Then there's the temperature sensor, which you could use to automate heating or cooling fans. And lastly, the sound sensor. Picking the right sensor is pretty much step 1 for bringing your project to life.
Moving on to Section 3, crucial safety rules. Protecting the inventor. We have our tools ready, but before we get our hands dirty, we have to talk safety.
Let me be incredibly clear about this one. Danger. Never connect electronic circuits directly to AC mains. That means do not plug your beginner circuits into the wall outlets. It is a severe, life-threatening hazard. You must always use appropriate low-voltage power sources, like simple batteries, when building these introductory projects. There's absolutely no bypassing this rule.
But hey, safety isn't just physical these days, it's digital too. Internet safety. Do not share personal info or download without help. When you're surfing the web for circuit designs or bits of code, always ask a teacher for help. Be super careful not to randomly download files and never hand out your personal info while researching your build.
And finally, workplace safety. Keep the workspace organized and free from unnecessary wires. Seriously, avoiding that giant spaghetti monster of tangled cables prevents accidental short circuits, stops your delicate components from getting fried, and removes tripping hazards. A clean desk is a sign of a focused inventor, right?
Which brings us to Section 4, building your system, bringing it to life. We've got our protocols locked in, so let's see how this goes from an idea in a textbook to a physical, working project. The very first step of building? It's actually just looking around. Observation first. Explore automation systems around you, like elevators or calculators. Before you wire anything together, just observe how things function in your classroom, your home, or out in the community. Watching these existing systems do their thing really helps you grasp the core logic behind automation before you try to replicate it yourself.
Once you've done your observing, it is time to execute. Here are the steps for building the project. 1. Make the electronic circuits to establish your hardware foundation. 2. Write simple programs giving your circuit its logic and instructions. 3. Select the appropriate sensors we talked about, plugging in the senses. And 4.
The absolute best part: test the automation system to watch it finally spring to life.
And that brings us to Section 5, Review and Reflect, the Koshal Bose. Now, you might think testing is the finish line, but a true inventor always evaluates their work. Let's look at the textbook's reflection questions.
Did your circuit work the first time? If not, please write down what you need to fix. I love this question because it actively normalizes failure. Spoiler alert, in real engineering, your circuit is almost never going to work perfectly on the very first try. Troubleshooting and fixing those little bugs, that is completely normal, and honestly, it's the most vital part of learning how things actually work.
Did you modify the code received from other sources? Mention the site and modification. If you grabbed some code from the internet and tweaked it, you need to document that process. Note the exact website and the specific changes you made. This is all about professional integrity, making sure you always give proper credit to the online community and resources that helped you get your project across the finish line.
Next up, you need to draw the final block diagram, sketch, or circuit of your working automation system. Look, having a messy tangle of wires that miraculously works is one thing. Stepping back and drafting a clean, visual blueprint of your finalized, successful build so that someone else could actually recreate it is what separates a hobbyist from a real engineer.
Did your system work as per the plan? What will you change next time? This question hits the nail on the head. Building tech is a cycle of continuous improvement. You build it, you observe it doing its thing, and then you immediately start brainstorming how to make version 2.0 even better, faster, or more efficient.
Let's wrap up this explainer with one final pretty provocative thought straight from the text. What precautions must be taken to protect circuits from electricity fluctuations? Think about it. Once you've poured your heart into building this amazing automated system, the real world is going to throw challenges at it, like unpredictable power surges. How do you actually keep your new invention safe out in the wild? It's a fantastic engineering question that leaves us pondering the real-world stakes of our creations. And I think that's the perfect place for us to pause our journey for today. So keep observing, keep building, and always stay curious.